Look up. That airplane crossing the sky weighs over 70,000 kilograms. And yet, it flies. But here's the real question. How does something so heavy leave the Earth? The answer is not just engineering, it's geology. Every aircraft is built from minerals that ferment deep inside the Earth, under extreme heat and pressure, over millions, even billions of years. From tropical soils, to molten rock, to ancient ocean deposits. Today on Geology Wonders, we reveal the hidden truth. Airplanes are made from the planet itself. Part 1: Fuselage of their plane made from aluminum from its or bauxite. Let's begin with the fuselage, the main body of the airplane. It must solve an impossible challenge. Be light enough to fly, but strong enough to survive extreme air pressure at high altitude. The solution begins in tropical regions of the Earth. In places with intense rainfall and heat, rocks slowly break down through chemical weathering. Over millions of years, this process concentrates aluminum-rich minerals, forming bauxite. Bauxite is not a single mineral, but a mixture of aluminum hydroxides like gibbsite and boehmite. Once mined, bauxite undergoes the Bayer process, where it is refined into pure aluminum oxide. Then comes the Hallich-Rold process, where powerful electric currents separate aluminum metal from oxygen. The result? A metal that is 3 times lighter than steel, highly resistant to corrosion, extremely strong when alloyed with elements like copper, magnesium, and zinc. That's why nearly 80% of an aircraft structure relies on aluminum alloys. So when you see an airplane shining in the sky, you're looking at ancient tropical rock, transformed into flight. Part 2: Wings of the plane makes from titanium. Now, the wings, the structures that literally defy gravity. Wings generate lift, but they also endure constant stress, air pressure differences, turbulence forces, repeated flexing during flight cycles. To handle this, engineers combine aluminum with one of the most remarkable elements on Earth: titanium. Titanium originates from minerals like rutile and ilmenite, commonly found in coastal sand deposits. Extracting titanium is extremely difficult. It requires the Kroll process, where titanium is separated at high temperatures in an oxygen-free environment. Why go through all that effort? Because titanium has extraordinary properties: strength to weight ratio higher than steel, exceptional resistance to corrosion, ability to withstand extreme temperatures. This makes it critical for wing supports, fasteners, structural reinforcements. Modern aircraft also use carbon fiber composites, made from carbon-rich precursor materials. These composites are lighter than aluminum, stronger in tension, resistant to fatigue. Together, these materials allow wings to be both flexible and incredibly strong. Part 3: Jet engine, extreme mineral science to make the plane engine. Now, we enter the most extreme environment in aviation: the jet engine. Inside the combustion chamber, temperatures can exceed 1,500 degrees Celsius, hotter than volcanic lava. At this temperature, most metals would fail instantly. So what makes jet engines survive? The answer lies in superalloys, advanced materials built from multiple minerals. Key elements: nickel from pentlandite ores forms the base of superalloys, maintain strength at high temperatures. Chromium from chromite prevents oxidation and corrosion. Cobalt stabilizes structure under heat stress. Molybdenum increases creep resistance, prevents slow deformation. Titanium and aluminum add strength and reduce weight. These elements are carefully engineered into turbine blades. Some blades even contain single crystal structures, meaning they have no grain boundaries, making them far more resistant to failure. Jet engines are not just machines. They are masterpieces of mineral engineering. Part 4: Landing gear, iron and steel. Now imagine landing. A massive aircraft drops onto the runway at high speed. The landing gear must absorb enormous force instantly. This is where iron becomes essential. Iron is extracted from ores like hematite, FeO, magnetite, FeO. Through smelt, iron is transformed into steel, then strengthened with elements like carbon hardness, manganese, impact resistance, chromium, corrosion resistance. This creates landing gear capable of handling thousands of landings without failure. Part 5: Electronics of the plane, hidden minerals. Modern aircraft are not just mechanical, they are digital systems in the sky. And this depends on critical minerals. Quartz silicon used in semiconductors and microchips, copper electrical conductivity found in wiring throughout the aircraft, gold reliabilityist in connectors because it does not corrode. Silver maximum conductivity, lithium energy storage powers onboard battery systems, rare earth elements like neodymium used in high-performance magnets for navigation and sensors. Without these minerals, there would be no communication, no navigation, no control. Part 6: Global Geology Connection. Every airplane is a global geological story. Bauxite from Guinea, nickel from Indonesia, titanium from Africa, rare earth elements from China, iron from Australia. A single aircraft represents millions of years of Earth processes, combined worldwide. So the next time you see an airplane in the sky, remember this. It is not just a machine. It is tropical soil turned into aluminum, deep earth metals forged into ingenious minerals, guiding it across continents. It is the Earth in motion. If you want to uncover more hidden geological stories like this, subscribe to Geology Wonders.